All right, calculus, looking at number 36, our old left endpoint rectangles. I kind of wanted to do 36 because I really like how they've got this Desmos tool in here and some homework help. Just highlight a couple other options for us, of course. But we want to approximate the area from -3 to 3 by finding the sum of the areas of the 6 left endpoint rectangles. So they have the left endpoints, and we know they're left endpoints because in this rectangle, its left one touches there. So there's 1, 2, 3, 4, 5, and 6. So they kind of almost try to confuse you a little bit by throwing this one in there. This one, we're not even going to calculate because it's outside of the 3. So the base of each rectangle is 1 times its height. And the heights are going to come from right here. So the height of the first one is 2/5 times -3 squared plus 1. That's the height right there. I mean, you could estimate it at 3.5, which is pretty close. But that would be the actual height right there. Plus 1 times 2/5 -2 squared plus 1. Dot, dot, dot. So if we add those up, that's where we're going to end up getting the answer that we want. And as we look ahead in that question, I guess if you do add those up, I think you should get like 13.2, is that correct? And then it asks in B, is this estimate too high or too low? It's just such a silly question for this one, because it really looks like this kind of matches up with this. This matches up with this, and this matches up with this. So you could say totally appropriately that, geez, it sure seems like it should be very close to the right answer. What I would comment on is that it's probably going to be a little high because of the concavity over here being a little bigger than the concavity down here. So because this one is concave down, I would argue that this piece is going to have more area than this piece. Therefore, it's going to be slightly above. So I think actually maybe this was 13.6. Yeah, this was 13.6. The actual answer is like 13.2 if you really calculated it. But that's getting into some pretty fine details there. In C, we want the right rectangles. Now this is the right rectangles, and I think that you should be able to see that that should add up to the exact same thing again. So 13.6. And then having the discussion in D, should the lefts always equal the rights? And I hope you mentioned something in your discussion about symmetry, really. That because we went from -3 to 3, and because it was symmetric about the y-axis, its lefts and rights should always be equal. But now, had we gone from, say, -3 to -2, its lefts and rights would be different. I think I can show you that here. Had we gone from -3 to 2, its lefts would be 1, 2, 3, 4, and 5. But its rights would be, let's get a different color here. Its rights would be 1, 2, 3, 4, and 5. So you can see this left had definitely the higher one there. So because of the symmetry, they were equal. But that would be the only time it would happen. All right, I like this question. I think you should check out this Desmos tool. It's got some circles there for you to click buttons on. Give it a shot.